Last section. So now we're going to put it all together. So one thing we might need to talk about, depending on what kind of calculators we have, we need to talk about the change of base formula. So many calculators, you're trying to figure out, for instance, what log base 2 of 5 is. There's really no easy way to do that. Most calculators are too dumb and too inexperienced. They just don't, calculators can't really do that. So we have to do something called the change of base formula. So basically what that means is if you have log base a of m, that's the same as log of any base of m over log of the same base of a. So if it's log base a of m, that's the same as log of any base of m over log of any base of that a. Now, how can that be helpful? Well, our calculators can't do log base 2, but it can do log base 10, which is the natural log, or the common log, right? So that's also, we could have log of m divided by log of a, right, with the base 10. Our calculators also can do log base e, which is the natural log. So if you're trying to figure out log base a of m, you can also do natural log of m divided by natural log of a. So if we're trying to figure out log base 2 of 5, right, if we're doing it with common logs, that's going to be log base 10 of 5 over log of 2. Which, if you plug that into your calculator, you should get that's about 2.32. If we do it with natural logs, log base 5 of, or log base 2 of 5, that's the same as the natural log of 5 divided by the natural log of 2, which again is the same answer. Good. So this is how we're going to get approximated answers, doing it this way. All right, so here are some 4 strategies when trying to figure out solving logarithms and exponential function equations. So number 1, first thing we can do is we can reduce either the 2 logarithms or the 2 exponentials with the same bases to equal each other, right? So have base to a power equals same base to a power, or log base a log of the same base, right? We can get it try to get it to that, either using the logarithmic laws or the exponential laws. All right, step 2. Another thing we can do, we can change the form of the equation. So if you're in exponential form, change it to logarithms. If you're in the logarithm form, change it to exponentials. That might be another way to do this. Number 3, we can solve some sort of quadratic type. So it may basically be a type of problem that looks like a quadratic. So we may be able to do that using U substitution. And then lastly, this is only for exponents. So if it comes down to it and you are just have no clue what to do for an exponent problem, you also always can take either the common logarithm or the natural logarithm of both sides. And this actually might be easier to do than to change it into a logarithmic form, potentially. But we'll see an example of that. All right, so here are your strategies for solving logarithmic or exponential equations. So let's look at example number 2. So for all these problems, we want to give the exact answer and a rounded answer. So keeping that in mind, let's do 3 to the x equals 21. Well, 21 is 3 and 7, so it's not 3 raised to some power, right? So we're not going to be able to get this to equal a base to a power and the same base to a power. So something else that we could do, so we can't do the first one, so let's try to change the form of it. So it's in the correct form, so we can see that if we change it to log form, it's going to be... Oh, pin's not working for some reason. All right, there we go. So log base 3 of 21 equals x. All right, log base 3 of 21 equals x. And there we go. We have our answer. Here's our final answer. Here's the exact answer. And then, of course, to get the approximation, right, if we have log base 3 of 21, remember the way to do that is using the change of base rule to plug it into your calculator. So you can do the natural log of 21 divide by the natural log of 3. And we should get about 2.77 if you round to 2 decimals. So here's our two answers. Here's the exact answer, log base 3 of 21, and the approximate, 2.77. All right, let's do another one. So we got 5 to the 2x plus 1 equals 6 to the x minus 2. All right, so can't turn 6 and 5 into the same base, right? So we can either do the log, we can either change it to the logarithmic form, or what we can do, strategy number 4. So I'll show you why this might be an easier way of doing things, and then we can do it the other way as well. So if we take the log, the natural log of both sides, all right, so now we have the log of something raised to a power and the log of something raised to the power, right? So we can use the log law number 3, right? We can bring those exponents out front. 2x plus 1 times the natural log of 5, x minus 2 times the natural log of 6. All right, so a lot of times people just get super confused. This natural log just messes people up for some reason. So if you want to think about it, right? A lot of times students are just like, I have no clue where to do this, but by this point, this is super easy. How would you solve a problem that looked like this? Right? If you solve a problem like this, most people would be like, oh, I would just distribute, right? And that's what we're going to do here. So we get 2x times the natural log of 5 plus the natural log of 5 is x times the natural log of 6 minus 2 times the natural log of 6. And now what do? We're trying to get x's by themselves, so let's get all the x's to one side, all the numbers on the other side. So we get 2x times the natural log of 5 minus x natural log of 6 equals negative natural log of 5 minus 2 natural log of 6. Now we're just 2 steps away from finishing this, so we're really close. So what can we do to the left side to where the end result is x equals something? So notice this one has an x and this term has an x. So we can just take an x out, right? So we get 2 times the natural log of 5 minus the natural log of 6 is the negative natural log of 5 minus 2 natural log of 6. So when you divide, you end up with x is negative natural log of 5 minus 2 natural log of 6 over 2 natural log of 5 minus natural log of 6. And this is totally okay as the final answer. If you want that to be the exact answer, you don't have to simplify any more than that. That's perfectly okay for me. Now, this should be relatively easy to plug into our calculators, right? Because natural logs are really easy. So when we plug into the calculator, we should see that we get about negative 3.64. Now, I did say that there was another way we could do it. We could do it using, instead of strategy 4, we could do strategy 2. So let's take a look. If you like that, just feel free to ignore what we're about to talk about. And you can just skip on ahead to the next example. But for those of us who are thinking, no, I think I would have used strategy 2, let me show you how you can do it. And let me show you why that's probably not ideal. And that's mostly when it comes just to figuring out what the approximation is. So if we have 5 to the 2x plus 1 equals 6 to the x minus 2. So we can do the snail method. We can turn it to logarithms, right? So it would be log base 5 of 6 to the x minus 2 right, equals 2x plus 1. And we can do the same thing that we already did, right? We can bring out that exponent, right? That's the log number 3 law. So x minus 2 times log base 5 of 6. Then we can distribute that log. So x log base 5 of 6 minus 2 log base 5 of 6 is 2x plus 1. We can get all the x's to one side, all the numbers to the other side. So x log base 5 of 6 minus 2x equals 1 plus 2 log base 5 of 6. We can see that both of these have x's, so we can factor that out. Log base 5 of 6 minus 2 equals 1 plus 2 log base 5 of 6. And we can just divide, right? So x is 1 plus 2 log base 5 of 6. I'm just going to put it in a different form so it looks a little better. So that's negative 2 plus log base 5 of 6. So this is also the correct answer. However, when we are trying to plug this into a calculator, right, what we're going to have to do is put 1 plus 2 times the natural log of 6 over natural log of 5 divided by negative 2 plus natural log of 6 divided by natural log of 5. And now we have fractions within fractions, which just, for some people, that's a little too much for the calculator to figure out. But if you do it correctly, you still will get negative 3.64. So again, if you can figure this out on your calculator, that's totally fine. But, right, doing it the other way might be a little easier and a little nicer, right? You have a fraction over a fraction. Sorry, you just have one fraction, right? There's no fractions within fractions. So that's why I like doing it this way better. But if you like the other way, feel free to snail it up. All right, let's do another one. So example number 4. So we have 5x minus 5 to the negative x over 2 equals 3. Well, remember, rule number 1, fractions suck. Get rid of them. Right? We can do that by just multiplying everything by 2. So we get 5 to the x minus 5 to the negative x equals 6. So rule 1, fractions suck. Get rid of them. Rule 2. Oh, so we have 2 rules in this class now. Negative exponents suck. Get rid of them. So how can you get rid of a negative exponent? Well, how can we make that negative a positive? So remember, the negative exponent just can go on the bottom. So that'd be 1 over 5 to the x. Now we're back at rule number 1, right? Fractions suck. Get rid of them. So this time we'll just multiply everything by 5 to the x. So we see that we have 5 to the x times 5 to the x, which I would like to put it as 5 to the x squared. Right? These two are going to cancel, so we get minus 1 equals 6 times 5 to the x. So if we put everything to one side, we would see this is 5 to the x squared minus 6 times 5 to the x minus 1 equals 0. Now notice you can't simplify this anymore, right? Because exponent happens before multiplication. But this kind of looks like a quadratic, right? Which goes to our strategy number 3. Right? We have something squared minus something, right? Minus a constant. So what we can do is we can just let u be that x to the 5. Sorry, 5 to the x. And now we got u squared minus 6u minus 1 equals 0. So now we can just solve that pretty easily. Well, factoring isn't going to be something that we can do, right? 1 and 1, that's not going to get you negative 6. So we can just use the quadratic formula. So negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times negative 1 over 2 times 1. So we get 6 plus or minus the square root of 36 plus 4 over 2. So 6 plus or minus square root of 40 over 2. And then 40 can simplify into 2 square root of 5. Oh, never mind. That's 4 and 10, which would be 2 and 5. So it would be 4 or 2 square root of 10 over 2. So to simplify that, right, we see that it's going to be 3 plus or minus square root of 10. And we're done, right? Hopefully you said no, because we don't care about u. What do we care about? We care about x. So remember, u was 5 to the x. So instead of u equaling this, 5 to the x will equal this. Which means now we have two equations. Right? First equation, 5 to the x equals 3 plus the square root of 10. Second equation, 5 to the x equals 3 minus square root of 10. So since we have just one exponent, right, this might be easier just to turn it into logarithms. So last time, for example, number 2, it's because we had two things being raised to a power, which is why it was a little tricky, right? But since only one thing's being raised to a power, logarithms probably be the best way of doing it. So we get log base 5 of 3 plus square root of 10 equals x. So here's our exact answer. Then we plug that into a calculator. We see that x is going to be about 1.13. We can do the same thing with this side, right? Log base 5 of 3 minus square root of 10 equals x. When you plug this into a calculator, you see that x is about, ooh, error. Why would you get an error? Because if you notice, this is going to be less than 0, right? Because 3 minus 3 is 0, so that'd be 3 minus the square root of 9. So if you do something bigger than that, that's going to be less than 0, right? And you can't take the log of a negative number. So this part has no solution. So the only solution we get is this one, right? Log base 5 of 3 plus square root of 10, or about 1.13. And we're done. That was it. Do we have to check ourselves? No, right? Because we started with exponents. Yeah, so far all of them we've started with exponents, so we don't have to check ourselves. However, we will have to this time. All right, so let's look at this. So we got log of the cube root of x equals the square root log of x. Now, notice when it comes to the log rule number 3, right? When you bring out the exponent, that's only if you're taking the log, right? If what you're taking of is raised to an exponent, right? So this whole thing is being raised to the 1/3 power. So we can take out a 1/3 here. However, we see that the entire thing here is being raised to the 1/2 power, not just what we're taking the log of, right? Do you see the difference? So here we're taking the log being raised to an exponent, right? The log of whatever we're taking, this x is being raised to an exponent. Here, that's not what's happening, right? The entire thing is being raised to an exponent. So this does not apply to the rule number 3, right? Law 3. Woo, that's a tongue twister. So that is actually as simplified as we can go. But how do we solve a square root problem, right? So if you notice, we have log base x, log base x. If you would like, you can use u substitution again. So you can use it for log of x. Sorry, not log base x, log of x, right? So we got 1/3 u is the square root of u. So how would you solve this problem? Well, we could, since we have a square root, get rid of the square root, right? So that could be rule 3. Square roots suck, get rid of them. Man, a lot of things suck in math. So, how can you get rid of it? You square both sides, right? So, on the right side we get u. On the left side, we get u squared, but we also need to make sure to do 1/3 squared, so that would be 1/9, right? All right, so how would you solve a problem like this? Hopefully, you know we can't just divide by u because u could equal 0, right? So we can subtract minus u equals 0. And then we can see that you can take out a u, right? Well, now we have two equations. So either u equals 0, right? Which is what we said why we couldn't divide, because it could equal 0, or 1/9 minus u equals 0. And since we said that u was log of x, we can just substitute that in, right? Log of x equals 0. 1/9 log of x minus 1 equals 0. So in the first case, how do we figure out what x is? Well, we can do snail it up, right? Turn it into the exponential form. So this time it's base what? Base 10 of 0 equals x, which means x is 1. And then for here, we can just simplify. So we see that if we multiply everything by 9, right? Get rid of all the fractions. Log of x minus 9 is 0, so log of x equals 9. And again, we can snail it up. So we get that 10 to the 9th equals x, which of course would be 1 with 9 zeros at the end of it. Do we have to check ourselves? Yes, because we started with logarithms, right? So we are taking the log of two different things, the cube root of x and x. So that's what we have to check ourselves with. So let's give a little more space so we can check. So we got to check for the cube root of x and for just x. Well, x is pretty easy, right? Because 1, that was one option, right? Is 1 bigger than 0? Yeah. We have 10 to the 9th. Is that positive? Yeah. Good. All right, then we got the cube root of x. Is the cube root of 1 positive? Yeah, because that's just 1. Good. Is the cube root of 10 to the 9th positive? Yeah, because that's just going to be 10 to the 3rd, which is also positive. So that means that both of these are the answers. We have two answers this time. 1 and 1 billion? Yeah, 1 billion. All right, let's do another one. So here we go. Let's try to solve this one. So we have log on one side, we have logs on the other side, so we're probably going to do it using strategy number 1, right? Getting a log with a base equals log of the same base. So before we can do that, we have to combine the right side using our laws. So with one logarithm, right, since they're adding, we're just going to multiply them. So 2 over x times 3x minus 5. And actually this should be have parentheses like that. So log of a base, log of the same base. So we get x minus 1 equals, and we can put this if we want to combine the fraction, right? So just distribute that to 6x minus 10 over x. Rule 1, fractions suck, get rid of it. So we can multiply everything by x. So the left side will get x squared minus x. Right side will get 6x minus 10. Move everything to one side. X squared minus 7x plus 10 is 0. So we can see that that's x minus 5 and x minus 2. Which means that x is 5 and x is 2. And we're done. No, right? We got to also check all of the logarithms. So this time we have to check x minus 1, right? Because that's what we're taking the log of. We have to plug in x and make sure we get a positive answer. We got to check 2 over x. And then we also have to check 3x minus 5. All right, so 5 minus 1 is 4. That's positive. We're all good. 2 over 5. That's positive. We're good. And then when we plug in 5 for this one, 15 minus 5 is 10. That's positive. So we're all good. So 5 is definitely an answer. And let's try 2. So 2 minus 1 is 1. That's positive. We're all good. 2 over 2 is 1. That's positive. We're good. And then 2 times 3 is 6 minus 5 is 1. All right. So in this case, both of the answers are correct. So we do end up once again with 2 different answers. But like I said, it's important that we have to check that. 2 more problems, and then we're done. Oh, I guess I didn't write the other 2 problems. Oh, that's fine. I can just write them on my own. All right, so example 7, same thing. So 3 times 3 to the x plus 9 times 3 to the negative x equals 28. 3 times 3 to the x plus 9 times 3 to the negative x equals 8. 28, excuse me. All right. So there's a couple things we can do here. One is negative exponents suck, so get rid of them. So we can see this is 3 times 3 to the x plus 9 over 3 to the x equals 28. And if you want to go ahead and try this on your own, see what you did, see if you can get the same answer I do, that's totally cool. There are lots of ways of doing this problem. I'm only going to do it one way because there's way too many ways of doing it. But if you want to just take a picture of it, of whatever your work is, and see if what you did is okay, I can definitely take a look at it. You can show it to me and I can tell you if you did it right or not. But another way to do it is see if you get the same answer I do. All right, rule 1, fractions suck, get rid of them, so we can multiply everything by 3 to the x, right? So that's going to be 3 times 3 to the x squared plus 9 equals 23, or 28 times 3 to the x. All right, so hopefully we can see that this is kind of a quadratic, right? So u equals 3 to the x. So we get 3 u squared minus 28u plus 9 equals 0. So there's lots of ways of going about this. If you would like to do quadratic formula, that's fine. I'm going to do factoring. So we can factor by grouping. This is the way I do it. So we need to know what 2 numbers multiply to get you 3 times 9, which is 27, and adds gets you negative 28. So hopefully you can see that would be negative 27 and negative 1, right? These 2 numbers multiply, get you positive 27, and adds to negative 28. So then we can rewrite our equation using these 2 numbers. So minus 27u minus 1u plus 9 equals 0. Then we want to group them up. So we group up the first one and we group up the second one, including that negative. Make sure to include the negative if you're doing that. All right, take out a 3u. You end up with u minus 9. Take out a negative 1. You have u minus 9. All right, what's in common with both of these? U minus 9, so we can take that out. And we're left with 3u minus 1. So we get 2 equations. First one is u minus 9 equals 0. Second one is 3u minus 1 equals 0. Since we said u was 3 to the x, we can just solve that, right? So 3 to the x minus 9 equals 0. And 3 times 3 to the x minus 1 is 0. So for the first equation, if 3 to the x equals 9, what's x? Well, it's just 2, right? 3 squared is 9. 3 to the x equals 3 squared, so x is 2. For the second one, right, if we solve it, so we can see that 3 to the x is going to be positive 1/3. And how can we turn 1/3 into 3 to a power? It's 3 to the negative first, right? So x is negative 1. Do we have to, are we done? Do we have to check ourselves? No, right? We actually don't have to check ourselves because we started off with exponentials. We didn't have logarithms. So we're actually fine. We don't have to check ourselves. This is the answer. All right, last problem. Number 8. And then we will call it a day for this. So we get log of x cubed equals log of x cubed. Log of x cubed equals log of x cubed. So which one of these two can you use the log rule with? Right? Can you bring the 3 out? So remember, this is the only thing we're taking of, right? The log of that's being raised to a power. So this is the one that you can bring the 3 out front. So this is 3 log of x. Since this is cubing the entire thing, you can't simplify that anymore. All right. Since we're cubing a log, we can just use u substitution if that makes things look a little easier for us, right? So we can do 3u equals u cubed. And now, hopefully, this is an easier problem to solve, right? We can subtract to one side, get everything to one side. We can see that we can take out a u to both sides, right? So we can actually just see that we have 2 equations, right? U is 0, or u squared minus 3 is 0. So in the second case, since we already got u is 0, in the second case, right, we can see that that would mean u squared is 3. So then u is either positive square root of 3 or negative square root of 3. So we have a 2.1 and a 2.2. But u was the log of x, right? So for the first one, log of x equals 0. So that would mean 10 to the 0 equals x, right? Or x would just be 1. The second one, right? We would see that that would mean 10 to the square root of 3 equals x. All right. And then for the last one, same thing. Oops. Right, so that's just going to be 10 to the negative square root of 3 equals x. All right, so do we have to check ourselves? Yes, we do, right? We got to check x cubed, and we got to check x. So we got to check for x cubed and x. Well, if we check for 1, 1 cubed is 1, which is positive. And then 1 is positive. Good. So 1 is an answer. Let's check 10 to the square root of 3. So 10 to the square root of 3, if you plug into the calculator, that's going to be about 53.95, right? Which is definitely positive. So if we square a positive number, is that going to be positive? Yeah. So 10 square root of 3 is an answer, which is weird, but that's an answer. Let's look at 10 to the negative square root of 3. So remember, negative radical doesn't mean that it's a negative number, or sorry, negative to a power. Negative power does not mean it's a negative number. It means that you got to flip it, right? So 10 to the negative 3 is just 1 over 10 to the root 3, which would be about 1 over 53.95, which, is this going to be a positive number? Oh yeah, absolutely. And then again, if you cube a positive number, do you get a positive number? Yeah. So all 3 of these are answers in this case too. All right. Hopefully I gave you enough problems to be able to kind of get a gist of what these are going to look like. As always, if you have any questions, let me know.